Hello students, welcome again to this class of data analytics. Okay, so we were studying about the various charts that are used to um, plotting or to visualize the data or to graphically represent the data in case of one variable or in univariate statistics, right? So we have studied two charts, right? One was frequency distribution table and the other was histogram. So now at this point of time, I want to introduce you to one another concept. Okay, so basically we were talking about the data, right? Like we can collect the data manually or we can collect the data through sensors, right? So now here I want to uh, explain that there are basically two types of data. Okay, I will show you. There are basically two types of data. What are those? First one is qualitative data, and the second one is quantitative data. Okay, quantitative data. Now that these both are different. How? What it means? See, qualitative data is like it doesn't include numerical values, right? Like we can basically say that we are recording that which color of shirt is worn by every student, right? I am counting that or like this example. Here we are recording the data for favorite color, right? I am asking every student what is your favorite color. He is telling that my favorite color is red. Someone is saying yellow. Someone is saying blue. So you can't represent this data numerically. There is no numerical value for red color. There is no numerical value for blue color, right? So what is this? This is qualitative data. Okay. Another one is quantitative data, like weight of students, marks obtained by the student, height of student. That is the quantitative data, right? So there are basically two types of data. One is qualitative, and the another one is quantitative. So now in last class, as we have studied about histograms, now keep this in mind that histograms are used for quantitative data, right? Here you can see on x-axis in histograms, on x-axis we have numerical values. On y-axis there is frequency. That's okay. But what we are saying in case of quantitative data, we are basically finding out that our how many values are lying in particular domain or in particular range of numerical values. Okay, but in case of qualitative data, we plot the bar charts. Many students get confused between the bar charts as well as histograms. They find it quite confusing that what is the difference. So this is the only difference. Okay, histograms are used for numerical values for the numerical data. Bar charts are used for categorical values. Okay, this is categorical data. Here on x-axis you can see on x-axis we have categorical values. Okay, or we have qualitative values: red, blue, green, yellow, pink. However, in histograms we have numerical values. Okay, so yeah, so this is bar chart. So while plotting univariate data, as we have, you can see here we are checking about the favorite color of every student, right? So what it shows that in the class, 8 students have told that they have red as their favorite color. Okay, about 7 students have blue. Okay, about 5 have green, and then about 9 have yellow, and then similarly 6 have pink color as their favorite. Okay, so this was qualitative data. Okay, okay, so this further can be divided. Okay, I will show you. Let's say we are talking about quantitative data. This is important concept. I think at this point of time it is good to introduce these concepts. Okay, so quantitative data is further classified into one is continuous data, and the another one is discrete data. Okay, discrete data. What does it mean? It means in continuous data we can have fractional values, right? Like we are, let's say we are calculating the mean. Oh, sorry, we are recording the weights of our students. Now, weight of the students can be anything. It can be 60, it can be 60.5, 60.2, 60.3. So this is a continuous data, right? What is discrete data? In discrete data, there is not a possibility of fractional values. Okay, let's say I am saying that how many students are present today. Let's say I am recording the data for the attendance of the students. Okay, it can't be possible that 2.5 students are present. Either 2 students are present, 3 students are present, 50 are present, 100 are present. These fractional values are not possible. So that are all discrete data. And the another one where fractional values are possible, that is called continuous data. Okay. So this was the two types of quantitative data. Then another one we have qualitative also have two types. Qualitative data also have two types. First one is nominal data, and the second one is ordinal data. What is the difference between that? See, nominal and ordinal, these both are qualitative, but the difference is that in nominal data, there is no one data is not superior to another. There is no relation among the data. Okay. Now let's see here we are collecting the data about the favorite color of each student. Okay. Somebody has red, somebody has blue. You can't say that red is better than blue. They have no relation. These are completely independent. But in ordinal data, now let's say I am talking about what we can say good, bad. Okay, I am saying that I have four types. A performance of student can be best, good, fair, poor, and worse. Now the thing is that I know that best is better than good, and good is better than fair is better than poor, and poor is better than worse. Okay, but the thing is, it doesn't have any numerical quantity attached to it. Okay, we know that they are in a certain order. That's why it's called ordinal data. They are in a certain order, but they are not directly proportional to a certain value. You can't assign a certain numerical value. Yeah, we will see further that while doing the analysis, we can assign certain values to these ordinal data to make the analysis more simpler, or we can, so that we can get good insights. But as far as it is not basically numerical data. Okay, so we have two types of qualitative data: nominal as well as ordinal. Ordinal has a certain order, like we can have what is the size of the shirt. Okay, right. So that is also ordinal data, until and unless you are measuring exact centimeters. Yeah. So I hope it's clear with you what is quantitative data, what is qualitative data. And there are further types. In quantitative we have continuous data and discrete data, and in qualitative data we have nominal data and ordinal data. Okay. So yeah, so this was about bar chart, and at this point of time, we have introduced two concepts: qualitative versus quantitative. And I hope that you know now how histogram and bar graphs are different from each other. Okay, okay, moving on. So next we have frequency polygon. Okay, it is very similar to histograms. You can see, we might be seeing that this is almost a histogram. So what is done in frequency polygons? In frequency polygon, we are basically joining the midpoint of each of our bar, right? We are joining each bar, each of bar, that is called frequency polygon. And it is important when we are basically plotting various graphs on a single plane. Okay, let's say I have one is this, then I can plot one, another is above that, so that I can compare that which value is which. Okay, yeah, so this is frequency polygon. It is very it is the same thing, almost same like the histograms. It's just we are, rather than showing the complete bars, we are just joining the midpoint of those bars, and then we are saying that yeah, this is frequency polygon. Okay, you know that polygon is basically made from various sides, right? So it has many sides. It's kind of joining, like joining. We are joining each midpoint, so it's making many sides. So it's called frequency polygon. Okay, moving on. Next, we have pie chart. You might have seen this numerous times, right? So what is pie chart? So basically, we have a circular area. So that is proportionally divided as per the frequency, as per the distribution of frequency. Okay. However, it's not very useful. It's very useful. It is good pictorially, but yeah, it's not much preferred in data science domain. Okay, because you can. It's only good if you have very less number of categories. If you have many categories, then it makes it's quite difficult and it's quite complex to see, to visualize that how the data is varying. Okay, so yeah, it's not a very good practice to use the pie charts. But anyways, it's good. You can see that we can easily say here that the countries by the proportion of world population. So you can see that we can quickly observe here that India and China have very large population compared to other countries, right? So yeah, we can quickly see that. But in case we are collecting some data that has many categories, then it is very hard. As you can see, you can't easily differentiate between these, right? They all look the same. it's very difficult to differentiate these. So yeah, this is not a very good graph, but yeah, still it's used by many. So this was pie chart. Okay. So yeah, so we have discussed three charts. Okay, pie chart, we can see polygon and bar chart. So by this we have completed the univariate analysis. Now you know what is univariate statistics. You know what are the various charts that are used to represent the to make the analysis, to pictorially present the data. Okay, and you know the difference between the various types of data. Okay, so in next class we will study about the multivariate analysis and bivariate analysis. Okay, bye bye.